Hello everyone, my name is SYAFIQAH. Today we are going to learn about inertia in 15 minutes. Now let's look at the objective. What are the objectives that we are going to obtain from this topic? The first objective is by the end of the lesson, you are able to explain with examples the concept of inertia. Next, you can use your experimenting skills to conduct an experiment to find the relationship between inertia and mass. And the last objective is you are able to justify the effects of inertia in your daily life. Now, I will introduce the two situations. The first situation is a group of people are standing in a bus and the bus is initially at rest. When they stood in a bus which starts suddenly from rest, they are likely to fall backwards. Okay, the next situation is when the moving bus stops suddenly, what will happen to the passengers? Yes, they are likely to fall forward. So, the question is, what caused the two situations to occur? This can be explained by the concept of inertia. What is inertia? Inertia is the tendency of an object to remain at rest or, if moving, to continue its motion in a straight line at uniform velocity. Means that suddenly they happen, you cannot change the condition immediately. For example, when you sit in the car and there is suddenly emergency brake, then you will lunge forwards. So, the concept of inertia is explained also in Newton's first law of motion. Newton's first law of motion states that an object will remain at rest or move at uniform velocity unless acted upon by an external force. Now, let's look at the other examples that involve inertia. These are two tennis balls. The original state of tennis ball is at rest. You see what will happen to the tennis ball when the cardboard is pulled away quickly? Yes, good. The tennis ball drops straight into the glass. The inertia kept the tennis ball at rest. When there is no cardboard to support them, they will fall vertically downwards. The next example is also the same with the previous example. The coin falls into the glass after the cardboard was pulled. The coin maintains its state at rest due to the inertia and its fall into the glass due to the gravitational force. Okay, next we go to the next example where the chili sauce are forcing out from the bottle. In this example, chili sauce in the bottle can be easily poured out when the bottle is moved down fast with a sudden stop. The sauce inside the bottle moves together with it. When the bottle stops suddenly, the sauce continues in its state of motion due to the effect of its inertia. The last example is The driver is thrown forward in an accident. In this case, when a car brakes, the force from the brake slows the car but not the driver. The driver continues to move forward due to the inertia. After we talk about inertia, now we are going to look at the relationship between the mass and the inertia. So, this is an empty trolley, and the another one is the trolley full with groceries, where the empty trolley has smaller mass than the another one with groceries. Okay, let's think. Which one is more easier to push? Yes, the empty trolley is easier to push than the trolley with groceries when they are initially at rest, and when they are moving, it also is easier to stop the empty trolley than the trolley with groceries. Why this happen? It is because the empty trolley with smaller mass is easier to set in motion or stop from moving as compared to a bigger mass. So, what is the relationship between the mass and the inertia? The answer is the mass is directly proportional to the inertia. When the mass increases, the inertia increases, and when the mass decreases, the inertia decreases. We also can say the larger the mass of an object, the larger the inertia of the object. And the smaller the mass of an object, the smaller the inertia of the object. Next, let's look at the experiment which is related to the relationship between the mass and the inertia. So, the aim of this experiment is to study the relationship between the mass and inertia. We have three variables here. The manipulated variable is the mass of plasticine. The responding variable is the period of oscillation, and the constant variable is the distance between G-clamp and plasticine. The apparatus and material are stopwatch, G-clamp, hacksaw blade, and plasticine. This picture shows how we set up the apparatus. Okay, this is the G-clamp, and it is clamped at the leg of the table. This is hacksaw blade, and this is the plasticine which is put at the end of the hacksaw blade. Okay, next, let's look at the step. The first step is clamp the hacksaw blade tightly and horizontally. Next, place the plasticine with a mass of 30 grams at the end of the hacksaw blade. Then, displace the free end of hacksaw horizontally and release it so that the plasticine oscillates. The next step is record the time T1 for 10 complete oscillations by using the stopwatch. Repeat the step 3 and 4 for another reading of T2. And repeat step 2 to 5 using plasticine of mass 40 gram, 50 gram, 60 gram, and 70 gram. This is the example of the result. We have mass of plasticine here, the time for 10 complete oscillations, and we have T1 and T2 and also T average. So how we calculate the T average? T1 plus T2 and divided by 2. So we will get the T average. Okay, next we have the period of oscillations. Okay, when you plot the graph will look like this. Okay, this is the graph of periods against mass. From the graph, we can say that when the mass of plasticine increase, the period of oscillation of plasticine also increase. So, the period here is used as indicator. The period of horizontally oscillation in an inertia balance depends only on the mass of plasticine. So, what are the conclusions that we have here? Okay, the conclusion from this experiment is when the mass of an object increase, the inertia of the object also will increase. So you can do this experiment and analyze data and also plot the graph at home. Okay? Next, we are going to discuss on the effect of inertia in daily life. Okay, the first picture shows the landing of an aeroplane. The aeroplane after landing did not stop immediately. If it were to stop immediately, then the passenger will be thrown in the forward direction due to the inertia of motion at such speed. It had to travel quite a distance before it stopped completely. Okay, the next picture is about swirling of coffee. After you swirl a glass of coffee, the coffee does not stop swirling immediately. It continues swirling for some time, after which it stops. This happens due to the inertia of the motion of the molecules. The next example is long jump. In the long jump, an athlete has to jump the longest distance possible. The inertia of motion will give the athletes an extra advantage by allowing them to move a little further. To take this advantage, the athletes come running before taking the jump. The last example that I will show here is satellite in space. The satellite orbits around the Earth in a specified orbit. The satellite moves due to the inertia and there is no external force to stop its motion in outer space. So, the satellite orbits the Earth unhindered. Next, let's answer the questions about the inertia to test our understanding. Okay, the question number 1. The diagram 1 shows a technique used to tighten a hammer head by knocking the other end of the handle onto a peg. So, the question is, which law is applied in the above technique? Is it Newton's first law of motion or Newton's second law of motion or Newton's third law of motion or Newton's law of universal gravitation? So let's think about it. Which one is the answer? Yes, the answer is A. Newton's first law of motion. Very good. Okay, the next question is based on the picture. The question is, how does the inertia affect the motion of a park? Okay, this is the park. How does the inertia affect the motion of a park? Okay, let me show you my answer. The inertia of a park will keep it moving in a straight line at a constant speed in the absence of friction. The inertia of an object is the tendency to resist change in velocity. The more inertia of an object, the harder it is to change its velocity, which is the object's speed and its direction of motion. Next, Newton's first law states that an object at rest will stay at rest unless there is an unbalanced force that acts on it, and an object in motion will continue in motion at a constant velocity unless there is an unbalanced force acting
I
on
hope
the object. You can get the benefits from our lesson today. That's all from me. Thank you.